Awesome. Welcome back, space fans, to Space Store Live. If you're new here, this is Space Store Live. This is where we bring space to everyone. And one of our programs, which we have on here every other Tuesday at 7:30 p.m. with space experts and astronomers, Nick Howes and Terry Moseley, where we bring you the latest and greatest of space news. And today, I wish you a very happy new year as we bring you the very first Space Store Live Roundup of 2021. Hi, Nick. Hi, Terry. How are you guys doing?
I am fine.
Not bad, coping with lockdown too. For all of our viewers and listeners around the world, the UK is currently in a national lockdown again. So this is nice to talk to people.
Yeah, well, thank you so much. If you're tuning in live, it's going to be a great roundup. I hope you guys enjoy it. I'll leave Nick and Terry to it. I'll see you guys towards the end.
Cheers, Latch. Nice to be back. Nice to be back after a bit of a break. We've got a good news story to start with, or a kind of good news story, which is a lot of fun. So anyone who's watched the show in the past will know that we've covered the sad demise of the Arecibo radio telescope in quite some detail. This is a 305-meter wide radio dish, which up until quite recently was the largest single radio telescope in the world. Barely steerable, got overtaken by the Chinese Faulkes Telescope some years back as the largest. That's 500 meters wide. Very soon, the square kilometer array is going to come online in full, and that's going to be a kilometer across, but that's a different system where they're using interferometry and lots of smaller telescopes to effectively give them a huge aperture that's going to exceed the Hubble's resolution by 50 times, so they say, and be able to pick up a mobile phone at 10 light years. So these things are really, really important. Now, Arecibo was considered by the people of Puerto Rico to be really a national treasure. I mean, this telescope, we said this before, it's featured in loads of films. James Bond's GoldenEye, it got trashed at the end. Contact with Jodie Foster, fabulous film, again, featured heavily in that. What was interesting in Contact is actually what's really come to pass, in that the US National Science Foundation literally let this thing fall apart. And it's not kind of too inflammatory to say that. They almost didn't care. It kind of got to the state where it was falling apart and there was no additional funding to support it until it really started to fall apart. So early middle last year, it started to literally come apart. One of the cables snapped. The observation tower, which is a big bit you can see in the middle, hanging above the main parabolic dish below, that basically started to fall over and tip over. There was all sorts of discussions about what they're going to do to try and fix it. A hole had been punched through the main telescope itself. Then late last year, it all collapsed. So literally all the wires, the tension on the wires became too much, and the entire observation deck, which is that bit in the middle, as I said, that's the bit that kind of steers and allows it to receive the radio signals and is focused on the instruments. That basically collapsed and fell into the telescope, causing irreparable damage. I mean, literally beyond repair, or so everyone thought. So what now seems to have transpired is Puerto Rican government have taken it upon themselves to say, no, this is a national treasure. This is something of real historical and heritage importance to our country. So they've pledged $8 million into the cleanup of this. Now, when I first saw this number, $8 million, I thought, oh, it's fantastic. That's quite a lot, until you realize just how much it's going to cost to rebuild this thing. The current estimate on a rebuild for Arecibo 2, including a replacement of all the instruments, upgrades, obviously, etc., into every single component, is somewhere in the region of $400 million. Now, in the great scheme of things, compared to some of the things we're going to be talking about later in the show, it's not that big an amount of money. It's still a huge amount of money, don't get me wrong. But the science that's come from this over the 40, 50, 60 years almost that it's been in operation has been so immense that we really do need it. We've talked about this, I know Terry's mentioned this in the past, it's one of the only telescopes of its caliber and size in the northern hemisphere, and that's still going to be persistent to this day. The Chinese Faulkes Telescope team have said, yes, all the international astronomy community can now access FAST, but this level of latitude and where it's able to scan the sky and its radar capability in particular were really quite unique in terms of what it was able to do. And the SKA Telescope, I love to bits. You know, I've been passionate supporter. I used to work for the SKA many years ago. Square kilometre array homed in Jodrell Bank in the UK, but the two telescope systems are in South Africa and Australia. Absolutely phenomenal, but it's still not there yet. It's been decades That's still in planning and development, etc. So it'd be great to see this come back online pretty soon. But they've got so far, I think, 58,000 signatures from people saying this needs to happen. But it has to be signed off. So the National Science Foundation funding comes from the US Congress. Now, given the events of the last few weeks or the last few days, they've probably got a little bit more on their plate right now than to think about how we're going to rebuild a telescope in Puerto Rico. Terry, any thoughts on this? This is a biggie.
Yeah. There's a couple of angles. I think actually now they have got over 100,000 signatures.
Oh, wow.
Which means that Congress literally does have to respond within, I think it's 30 days to the petition. So they've asked for a report by the end of February at the very latest. Congress has, so they will want to have all the information available on what to do. As you say, 400 million is not huge in the scheme of things. As I mentioned before, when we talked about how significant the loss was, Arecibo is much closer to the equator than the Chinese fast telescope, so it can see things further into the southern hemisphere. There's also another angle, literally. It's more or less on the opposite side of the world to the Chinese one. The Chinese one is 107 degrees east longitude, and Arecibo is 67 degrees west. That means that they're covering the sky at any given time in opposite directions. And if, for example, there was a close approach from an asteroid, which would be below the horizon at the time of closest approach from the Chinese telescope, then Arecibo would be able to pick it up. And some of these objects are flying past so fast, or they're passing in daylight or something, that radar is really the only way to get a good idea of what they're like. So it's very important, I think, to have two big telescopes like that on opposite sides of the world. I also have a lot of sympathy with the Puerto Ricans. This really is, as you said, their national treasure. They really don't have anything else of great significance in Puerto Rico, certainly from the science point of view. And I think there's a lot of sympathy in the international community, sort of maybe an emotional sympathy rather than a rational scientific one, that it'd be good to see that back from their point of view. But there's definitely a science case to be made as well. It'll be much, much better than simply continually sort of tweaking and making little minor modifications and improvements to the radio telescope. This will be a complete rebuild, if it happens, on the same site. And it'll be state of the art in terms of the structure, the instrumentation, and so on. The cost of actually rebuilding it is the start. Then you have the staffing and the maintenance and so on. But I think it is capable of delivering so much that it's definitely worth it.
It's so important as well. You talk about the differences between the locations on the Chinese and this telescope. The very long baseline interferometry that's already capable across the Merlin network and all of the other radio telescopes around the world gives us an immense capability. And especially now with so many satellites, and there was even a report today on the BBC News that made one of the BBC News headlines talking about the imminent debris problem. So that is becoming a really serious issue that's being discussed now, not just in the scientific and the astronomy community, but in the wider community, because it is a growing and looming problem. From a radio telescope point of view, the telescope band 5B, for example, is going to be out of bounds already in terms of observations. But this capability may be one of the only ones we've got for potentially detecting hazardous threats coming in, things like large asteroids, as you said, Terry, if we get a close pass from one, being able to really accurately determine its shape, its size, its rotation, all sorts of things. This is going to be really important for the planet. So make no mistake, $400 million in the current context and the current scheme of things, obviously with global pandemic, is a lot of money. But the global pandemic has proven that science is the thing that can help save humanity. And this is really key science that's going to be needed moving forward. So I just really hope that Congress, National Science Foundation, and everyone else who wants to get behind this really does get behind it, and it goes kind of and becomes a thing. Moving over to China then for our second story, and this is a good one. I'm going to hand over to Terry on this because I know he's got a real passion about the Chinese space program. Their new space station, Terry.
Yeah, I have mixed feelings about China. They politically, there are lots of problems there, which I'm not going to go into. But in terms of science, yes, they're really going ahead in leaps and bounds. In terms of the space station, there's a little bit of background we need, and that is that the Americans, who are the prime contractors, if you like, and prime operators and funders for the International Space Station, exclusively forbid China from participating in that because they're afraid of the Chinese taking basically technological and IT secrets from it. You can probably get them in other ways, but that's another matter. So China is basically, I think, the only significant country in the world that is not allowed to participate in the ISS. So that's a bit of background. China, therefore, are going ahead with their own station, Tiangong. I'm not sure if that's the right pronunciation, but anyway. And as we've seen what they're doing in space now, when they put their mind to it, they really deliver. What they've done on the moon recently, as we talked at the end of last year, and their Tiangong craft and so on, is really, really amazing. They may have had failures that we don't really know about, but basically almost everything they're doing at the moment seems to be working. So they're already well underway in this. They have trained the astronauts. They've got the module built. They've got the launcher built. They're probably going to be doing some more testing, and then there will be a launch of the core module, and then they will add to that. Now, they haven't revealed all the details of what the final plan is going to be, but if they start off with something like the size of, say, the original Russian Mir, which was the first space station, and then build on that. Going back to the politics again, I think it's inevitable that sooner or later there's going to be international cooperation. Even if America decides not to join in with the Chinese station, other countries, particularly in the Far East, may well join in as well. There's always a quid pro quo. You contribute some money and you get some participation, some feedback, some science. So it's in a way, it's a shame that there has to be this competition and two space stations when one would do. The other angle, of course, is that the ISS is nearing the end of its useful life. There's considerable debate, particularly in America, about how long they're going to be funding it for. There's another angle then, what do they do with it after they stop funding it? They don't want it to come crashing down on top of the Washington Monument or the White House or anything like that. So you can't just leave it there, you have to do something. But assuming that the ISS does have a limited lifetime, whether it's 10 years, 15 years, 20 years, it will be good to have another state-of-the-art modern space station operating. And even if China reserves it totally for themselves, there will be some feedback, some outflow of information. And I would be very surprised if in the longer term they keep it entirely to themselves. I think there will eventually be some international cooperation on that space station. So it's something to be welcomed.
It's interesting as well, you talk about the ISS. The Russian plan at the moment is to, if the ISS is fully decommissioned, they're going to start stripping the modules for their own purposes. And you talked about Mir. Obviously, we go back to Skylab in terms of, space stations and the Salutes and various other space stations throughout, the course of the last 50 years. In terms of the extent of this, we don't know the full size and scale of it. It's probably not going to be on the same scale as the ISS in terms of the costing. If you think and remember, the ISS in terms of the combined cost of the shuttle launches and the shuttle maintenance and the build cost, we're looking at anywhere in excess of $200 to $250 billion in terms of the overall cost from development, initial R&D, all of the original plans. Don't forget, the ISS wasn't the original space station that was planned. The original space station that was scrapped in the mid-1970s was more of a kind of refuel staging post for potential Mars missions. So there's been all sorts of refinements in terms of the ISS itself and what the space station has now become. And it is still delivering, huge amounts of science and, being fully crewed now for decades. It is an impressive structure up there. It would be horrible to see essentially $250 billion crash into the Pacific Ocean and become a really nice dive reef, which is not what anybody really wants. There's talk of commercial companies, Axiom Space and various others talking about using it for hotels and putting habitat modules on it. And Bigelow have obviously got their inflatable module in test. So this one will be interesting because, again, what currently is happening with anything that China do, the US tend to feel like they have to respond in some respects, or vice versa. So if China were to have the only large-scale operational space station, and I don't think this is going to happen because you only have to look at what SpaceX are doing, obviously, with Starship. And Starship itself, if you were to repurpose, much like the Skylab was repurposed from the old Saturn V central core stages, the potential for putting up a large space station akin to Skylab is potentially within the US's reach with companies like SpaceX. So I think this is going to be an interesting one to follow. China's space program, secretive or not, it is really, really fascinating. And they, do not be surprised if there is a serious race. Probably not for the moon. I think Artemis, and we'll go on to that in a little bit, is going to probably get there before anyone else. But I think for Mars, I think China have got serious aspirations here, Terry. I don't know if you agree, but anyway.
There's one other thing we don't know yet, and that's the orbit. But assuming that as Chinese territory extends up to 53 degrees north, they will probably want to cover most of China, and that in fact would be very similar to the orbit of the ISS, which is about 51, 52 degrees inclination. So if it eventually sort of disappears from our sky, we might have something similar, maybe not quite as big and bright, but something up there that we can see.
Be interesting as well, given the US nervousness over anything that China do, as to whether or not some of the observations in inverted commas from the Chinese space station are very akin to that scrapped Gemini program from the 1960s, the MOL, the Mobile Observing Laboratory, which was basically just a gigantic, great big space station using repurposed Gemini spacecraft. So anyway, all interesting, definitely worth following. Moving on. This one's great. Stingray Nebula. So most people won't have even heard of this. This is Hen 31357. So this is not something your average backyard telescope's ever going to pick up on. It's literally this minuscule planetary nebula. Now, planetary nebula typically are formed end of a star's life, something like our own sun, for example. This is what it's going to look like in about 4.5 to 5 billion years. Once it's eaten through all of its hydrogen, helium, etc., essentially you're going to get this expanding shell of gas coming away from what's left of our sun after it's subsumed Mercury, Venus, made Earth uninhabitable, made Titan probably a really nice beach resort. There's all sorts of fun things going to happen. What's interesting with this, and Terry and I know this from being avid and passionate observational astronomers, when you're into astronomy, there are very few things that change in the sky. You can look at a nebula or a galaxy one year, and it pretty much is going to look exactly the same the next year and the year after that. And your observing techniques may get better. Your cameras might get better. You might get better images. But unless you're into observing the sun in hydrogen alpha, calcium K-line, white light, sodium, whatever, or you're interested in looking at Jupiter and its evolving cloud belts, etc., or Mars and the changes over the season, not a lot really changes up there. You'll get auroras, you'll get meteor showers, but space is essentially space. You're not seeing much change. What the Hubble has shown with this nebula is real change over a staggeringly short period of time. Urge anyone who's not seen this to go on like NASA's channels and YouTube, etc., and just see what's happening with this, because it really is changing over only a period of 20 years, where they're seeing this outer shell of gas really, really evolve and change. I found it fascinating, Terry. Any thoughts?
Yep, absolutely. One other thing I would add, just when the personal interest is variable stars, they do change over a short period.
That's true.
That's novae and supernovae. But for galaxies and nebulae, as you say, basically 20 years is a blink of an eye. They don't change in that period, but this one did. And just to let anybody sort of wonder what the origin of the name is, planetary nebulae, they have absolutely nothing to do with planets at all. But when the early astronomers with their rather primitive telescopes looked at them, they saw that they weren't stars. They were little round disc-shaped patches of light, so they thought they looked a bit like planets, and they got the name planetary nebulae.
Blame the Herschel family for that one, I think.
Totally out of date, but the name has stuck. And yes, as you say, it marks the stage near the end of a star's life. What they think happened with this one is that it went through a different phase of energy production in its core. The central star, as you can see in the image, is basically emitting ultraviolet light, which is making the gas shine, basically, so we can see it. We needn't go into the details of that. But that star is going through relatively rapid changes itself in its own evolution. They think what happened was that before the nebula actually started to fade, it brightened slightly. And they think that the central star went through a rapid phase of burning helium in the core, which produced an extra amount of energy. That made the nebula appear slightly brighter. But that phase of helium burning has now ended, and the star is getting cooler. and therefore it's emitting less ultraviolet light. Ultraviolet light is produced by much higher temperatures than the sunlight that we see on the sun. So it's no longer exciting the nebula to radiate in the wavelengths that we see. The original image, if you look that up, there's quite a lot of blue in it. That's from excited oxygen, and that comes from the ultraviolet radiation. So it's not that the nebula itself is actually disappearing. The gas is still there. It's actually slowly still expanding into space. It's just that the central star is no longer making it shine as brightly. But that in itself is fascinating, because there's still an awful lot that we don't know about the later stages in the evolution of the star. And this will, as you say, eventually happen to the sun.
What I've always found fascinating with these planetary nebulae as well, I mean, as you said, it goes back to the Herschels of this world from his observations in Bath, and between William Herschel and John Herschel, incredible polymath that he was. Some of their observations really did kind of set the name and this kind of object in stone, really. What I've always found really interesting and a potential area for astronomical research is you look at what's happening here. You've got an expanding shell, which is essentially encompassing everything in that star's solar system, for want of a better term. So if you've got large planetary bodies in there, the capability for some of the telescopes that we're going to have in the next few years, like the James Webb Space Telescope, to look in detail at these planetary nebulas and see if there's any kind of bow shocks appearing anywhere near what would have been essentially planets orbiting this star, and what's happening there. I thought that would be a really interesting area of research. Obviously, the resolutions and capabilities that we've got right now may not be up to it, but when the ELT comes online, all of the other huge telescopes being built in various locations like Hawaii and down in Paranal, and as I said, the James Webb and WFIRST, with its new name, all these things when they come online, I think it'd be really interesting to see, to get more direct observations of orbiting exoplanets, even though they're probably at the end of their life, as it were, because you really don't want to be in that.
There's one other thing I forgot to mention, actually. This is the youngest planetary nebula that we know of. So we're seeing it in a relatively early stage of its development. And not even your telescope will show you that one, because it's far down in the southern sky in the constellation of Ara, so it just never comes above our horizon. And as you say, the Hubble Space Telescope is really the only thing that can image it properly, because it is pretty small, because it's still quite young, and it's 18,000 light years away. There are other ones further away, but that's still a considerable distance. So good old Hubble to the rescue again.
Yeah, it's again going back to this things remaining like the ISS. To my mind, the James Webb is going to be a remarkable telescope, and everybody's got the fingers crossed that it all works, and that vast deployment out to its Lagrange point works flawlessly, and the Ariane launch works flawlessly. But the whole topic of decommissioning the Hubble and letting that burn up in the atmosphere as well, that's one for a future show, I think, because I don't think anyone wants to see that happen. Definitely not. Anyway, moving on. Hot topic. Speaking of hot topics, so this is a very hot topic, a real hot potato. The SLS, the Space Launch System. So this is NASA / the US government's official launch vehicle for the next moonshot. So the Artemis, which is the sister of Apollo, the Artemis plan is to put human beings back on the surface of the moon by 2024. Whether or not that happens is still up for debate. The issue with this is it's now into static test firing. So much like we've covered Starship and the SN6, SN7, SN8 in the past, the SpaceX launches from their grain silos out in Boca Chica in Texas. We've covered that in great detail, and they've had huge amounts of success, a couple of minor failures, as Musk puts it, where SN8 obviously didn't succeed for the entire mission, but still the flight dynamics and the flip maneuver, everything went flawlessly up until the landing stage, and he'll probably get that right in either the next one or the one after that. SLS is a whole different beast right now. So this project has been going on for decades, and so far, whilst NASA will say, oh, it's $8 to $9 billion, it's not. It's closer to $20 billion, this entire project. This is a huge consumer of NASA's budget. Obviously, the notion of human exploration, I'm a big fan of it. I know you are, Terry. There's lots of people who think we could do everything with robots. I don't agree. I think Apollo proved what we could do, and Apollo proved again, you know, how the entire world could get behind something really, really interesting. And it's still the greatest, you know, and please argue this with me if you ever dare to, the greatest technical achievement in human history. Artemis are aiming to put the first females on the moon. They're probably going to put the first person of color on the moon as well. So there's lots of geopolitical and political will for this to succeed. But then Congress has tried to can it on multiple occasions. Laurie Garver, even the deputy administrator at NASA, tried to can this entire project. The cost overruns and the fact that Boeing is consuming so much money with this is beyond, pardon the pun, astronomical. Now, what you can see there is the core stage. So they're now going through what they call the green run. They're going to do a test fire. And what you can see below that is the Stennis test fire facility. So this was used on Apollo. If you look at some of the old Apollo F1 engines, the Rocketdyne F1, now owned by Lockheed Martin, so it's no longer Rocketdyne's F1, it's LM's F1s, but they basically did all the test firings for those there. Now, the thing with the SLS is it's not using engines anywhere near the size of the F1s. These are the RS-25 engines. These are effectively just space shuttle, slightly modified space shuttle, well, somewhat modified space shuttle engines and modified SRB stages, so larger versions of the shuttle's solid rocket boosters. So if they fail, it's a one-shot, light this candle. If it all goes wrong, it's going to go very, very wrong. NASA won't commit to telling anyone what the launch cost is per mission on this, but it's estimated to be probably anywhere between 10 and 20 times what SpaceX are currently launching for. And Elon Musk himself has even said he could have built something akin to this in terms of size and scale. And that's what he's obviously aiming for with Starship for 1/10 of the cost. So the argument as to whether or not this should even exist when we've got things like Arecibo, etc., we've talked about before, is a really hot topic and one that Congress, again, have got to kind of get through. If this is to fail, who knows? It may fail. It may blow up. You know, SpaceX blow up stuff in test firing all the time. They've blown up objects on the pad and in launch. They've blown up Falcons after launch. So we don't want to see that happen. The first Artemis test launch is slated in for middle to late November this year. It may be delayed again. Who knows? It's been pushed back and pushed back and pushed back. Everybody wants to see this happen because, you know, this thing is the size of a Saturn V. It's the first rocket in 50 years that's been anywhere near this kind of scale and magnitude. The shuttle is minuscule in comparison to the Saturn V. This thing at 365 feet high for the Block 1 version, even higher for the Block 2 versions. You know, it's capable of lifting 95 tons into orbit, 135 tons apparently on the Block 2 version. I want to see it succeed, but somebody needs to really decide if this is the future, because this isn't even a reusable system in any way, shape or form. You know, those core stages, it's basically, it's a one shot. Yes, they'll probably be able to recover the SRBs, similar to the way that they did in the old space shuttle days, but true reusability has been demonstrated by SpaceX on multiple occasions. And now Ariane even saying, we've got to do this or we're dead. We're not going to be able to basically compete with SpaceX anymore. Has got to be the goal. And I just don't see how at anywhere between $500 million to $1 billion per launch, which is what some of the privately discussed estimates are, can really justify this spacecraft. Terry, I don't know what you think, but I'm sorry I ranted. But
No. I would agree with a lot of what you're saying. And money has never been really the major problem in America, certainly as far as the Apollo budget was concerned. They threw everything they had at it. But there was nothing else really, no private enterprise offering anything as an alternative. Whereas now we do. We have Elon Musk in particular and Blue Origin as well. And I would agree to a large extent with what you were hinting at there. If this thing blows up on the launch pad, I think there's a serious danger that they will just continue the program. As far as the SLS is concerned, they might turn entirely to the private sector with Elon Musk. But at the moment, they are pretty committed. They've got 16 engines, which they've basically repurposed from the shuttles, and they've just ordered another 18 from Rocketdyne in California. So that gives them enough engines to do. As you say, they will certainly need some more of the SRBs if they're going to continue to run that. The other thing that it's unfortunate to have to mention this, but basically the impact of COVID on the American economy is massive. It's almost incalculable. There may well be people that are arguing we have much more important things to do in terms of spending money to rebuild the economy than space. The other angle, of course, is that running the space program does provide jobs. You can argue it both ways. Again, without delving too deeply into the politics, Trump was quite keen on the space program and indeed the Space Force, I think more for sort of political kudos than because he had any interest in science. Biden isn't motivated by the same sort of thinking, but he's generally much more in favor of science for its own sake than Trump would have been. So it's all changed there. They have a completely new administration. Biden will be making new appointments, presumably in all sectors of the science side of things. And who knows? Like you, I would certainly like to see it succeed, but I don't think there's just the same commitment towards it as there was for the Apollo mission. Look what they did after the Apollo 1 fire in the spacecraft when they lost 3 astronauts before they'd even got a single astronaut up in space in the Apollo module. So, you know, it's a whole new ball game, and I think there's an awful lot of guesswork still at this stage, but I certainly wish them success.
I think you're right. I mean, I've said this, and politics aside, I think one of Trump's greatest achievements, probably his only great achievement, was the appointment of Jim Bridenstine, because Jim has led a really steady ship at NASA, and he was a passionate advocate for this as a program. Now, if you think that Biden's former boss was the one who cancelled Constellation, and as you said, he's got some massive problems to deal with. You know, he's got to get the American economy, he's got to get jobs back in, and yes, NASA employed tens of thousands of people, but then, as you said, it's the whole cost thing. Congress must be looking at this and thinking, well, hold on, if this guy out in Boca Chica can make the same thing for a tenth of the cost, what are we doing? Where are we going wrong? Do we need this? Or can we farm not just what we're doing in LEO space with Starlink, etc., but more into the exploration side? Let JPL and the various other NASA sensors carry on with the amazing work that they're doing. Don't get me wrong, I love everything that comes out of JPL. It's phenomenal. But it's going to be a really interesting one. My biggest fear is if this fails and the James Webb fails, you've then got $30 billion that you've got to account for. And that's going to be, I wouldn't like to say the death of NASA, because nobody would ever want to see that happen. They have inspired generations for 60 plus years now. It's not something anyone wants to see, but it's going to be catastrophic if they have any significant issues and things go wrong in space. Space is still very hard. So wait and see, as it were.
Yeah, as we mentioned earlier, there will be the rivalry with the Chinese. They could not bear to see China having a completely successful or very largely successful space program and NASA just being left to wither on the vine. I don't think that's going to happen.
No, that could be one of the key political drivers. So watch this space as it is. Right. Moving on to watching this space. Here's a good one. The ultimate conundrum. So 13 point whatever billion years ago now, our universe came into existence, or did it? This is the whole debate now as to the age of the universe and the Hubble constant. I'm going to let Terry go off on this one, because I know he's got something to say on this.
I won't accuse you of chickening out on this one, but I have to say that this is a really difficult hot topic. I'm not a cosmologist by any stretch of the imagination, but I'm fascinated by the subject. And basically this boils down to the age of the universe and how fast the universe is expanding. And the two things are sort of very closely tied together. If we can work out exactly how fast the universe is expanding, and then, if you like, run the clock backwards, we get back to the age at which the universe began, and that gives us its age. So how do you measure the size of the universe and the rate at which it's expanding? And there are two main methods. And again, as I say, I'm not a cosmologist, so if anybody in that category is watching, please excuse me. But basically, if you go back to what we know about the Big Bang, particularly results from the Cosmic Background Explorer, COBE, give us incredibly valuable and incredibly clean, accurate results for the cosmic microwave background radiation. plotting the points of the data from the COBE satellite on the theoretical curve was just a perfect match. It was almost too good to be true. So it looks as if the data from COBE and other measurements of the same sort of thing in cosmic background radiation seems to be pretty much on target. What you do is you take those starting conditions, you look at what happened immediately after the Big Bang and the 300,000 years after that and into the Dark Ages and so on. Don't have time to go into all the details. That gives you an expansion rate at the moment of about 67.4 kilometers per second per megaparsec. Now, that's a bit of a mouthful. You need to explain that. That means that taking the universe as a whole, other galaxies, excuse me, are expanding away from each other at a rate of 7.4 kilometers per second. That's pretty fast, but that's over a distance of a megaparsec, a million parsecs of space. And a million parsecs is 32.6 million light years. So for every step that you go out into the universe further away, 32.6 million light years, a galaxy will be expanding away 67.4 kilometers per second faster. So that's basically what that figure gives us. There's an error bar on that of plus or minus 0.5 kilometers per second. Okay, so that tells us from that particular set of observations in theory how fast the universe is expanding. There's another way of doing it, and that's basically observation on what we call the cosmic distance ladder, and you could do a whole program just on that alone. How do we know how far away things are in the universe? Well, it's relatively easy in our own solar system, but if you want to measure the distance to the stars and nearby galaxies and so on, it gets a bit more complicated. The first step on the rung, if you like, is parallax. The Earth's orbit is about 150 million miles across. If you observe a relatively nearby object 2 times 6 months apart, you will be looking at it from 2 points that are roughly 150 million miles apart. Sorry, 90. Yeah, that's right. I think I got mixed up here. Anyway, that gives you a geometrical measure of the nearby objects. You then use other techniques such as the characteristics of certain variable stars called Cepheids, and that gives you the next step on the ladder. You then have other things like the Tully-Fisher relationship, other things to do with globular clusters, the density and brightness of galaxies, the distribution of light across galaxies and so on. And that gives you other rungs on the ladder. And finally, we get to the most distant technique that we have, which is, well, there's the Tully-Fisher relationship, which I don't have time to explain, but type 1a supernovae, which we think all have roughly the same maximum brightness. So if you can observe a type 1a supernova in a distant galaxy, and you observe how bright it appears from the images in the photographs, and how bright it should be, because we know what the maximum brightness is, that tells you how far away it is by the inverse square law. The trouble is, when we do it that way, we get a slightly different figure. Not a huge difference, but one that's significant. And that gives us a figure of 74 plus or minus 1.8 kilometers per second per megaparsec. And the two error bars don't overlap. As I say, it's not a huge discrepancy, but it's a significant one. Then the latest information is that the Gaia satellite, which has measured the distances of objects in our own galaxy to an incredible degree of accuracy, and a much higher number of them, gives us a much more accurate measure of the first couple of steps on that rung. And when you apply that, we get now just a slightly different figure, but still with a discrepancy. The figure that we get now is 73.2 kilometers per second per megaparsec, with a slightly smaller error bar, 1.3. So ignore the error bars. We've got the difference between 67.4 and 73.2. And it's a significant difference in terms of cosmology. And the two should give the same answer, but they don't. So which one do we rely on? Do we rely on the information that we get from COBE and the theory of what happened to the universe as it expanded after the Big Bang and the cosmic background radiation measures, or do we go with the cosmic distance ladder? The trouble with the cosmic distance ladder is that if you get an error in one of the rungs of the ladder, then everything else beyond that is also in error. There are a whole lot of other techniques which tie in, far too many to list here, and they don't all agree exactly, but they're all fairly close in the second method of basically observational measurement, and we have this problem. So what is the age of the universe? As Nick said, the consensus seems to be round about 13.8 billion years, but it could be slightly different from that. And this is the whole sort of fascination of cosmology, trying to work out what actually happened way back then and what's been happening ever since.
Really is. And you look at the Hubble, I mean, you know, the greatest telescope ever conceived in the Hubble Ultra Deep Field, and the distances that can go back, you know, it's only barely scratching this cosmological dark age area, which, you know, if we are to believe that 13.81 billion years ago we had a Big Bang, or 13.7 billion years ago we had a Big Bang, you know, these values are several hundred million years out based upon what Terry was saying before. We're then looking at, you know, galaxy formation, early star formation, all of the things that telescopes like the SKA and the James Webb are going to be able to pick up in the coming years to a greater distance and greater resolution than the Hubble's even been able to do. This is going to start really opening up this can of worms as to what is the true answer. And I, for one, can't wait to see this all pan out. I've had this debate for decades with various people, even going back to the university days, with like, what is the true age of the universe, etc. So it's going to be fascinating to watch. I loved what you just said there, Terry. It was just so succinct. Why weren't you a university lecturer? It was really, I love that. It was so good.
Right. I've just realized what I was getting mixed up on there was the classic difference between the metric units and the miles. The 150 million is the radius of the Earth's orbit in kilometers, not the 93 million, which it is in miles. So that was for the 150 million.
NASA did it and crashed the spacecraft on Mars, so don't worry.
I know, that's a beautiful story too.
Anyway, moving on to... Oh, go on, sorry.
The diameter of the Earth's orbit is approximately 300 million kilometers.
So our last story before we talk about what's up, again, this is one we could debate for hours and hours and months and weeks and what have you. There is now a law being passed in the United States to give protection to the Apollo landing sites. So Apollo 11, 12, 14, 15, 16, and 17, obviously 13 didn't make it to the surface, but all of these landing sites are now protected, or supposedly are afforded protected status. Now, what's interesting here is, where do you define that protection zone? If anyone's read Andy Weir's novel Artemis, for example, and that's nothing to do with the Artemis missions that are going back to the moon, but Artemis conceived this idea of a lunar base, and one of the lunar bases was very near to one of the Apollo sites, so it was kind of like a tourist attraction. Now, in the coming decades, there is doubtless going to be a desire for people to see the original Apollo landing sites, be that, you know, as tourists orbiting and looking down from telescopes and seeing what's left of the descent stages, much as, you know, some of the lunar orbiters, lunar reconnaissance orbiter, etc., have been able to do for the past few years, or to actually go and look at the sites up close. Where you define the region of you can't go any closer than this is a really hot topic. So you've got all the original footprints placed there by Aldrin and Armstrong with Apollo 11. You've got the fact that on Apollo 11, they think that the flag has fallen over. All of the Apollo other flags they think are still upright, but are potentially bleached out. So is there an argument put forward that if you were to find and go to the Apollo 11 site, that you put the American flag back upright? Because it has lots of significance for many people in the United States and indeed around the world. It was a historic moment in human history. If you were to go there, what are you going to do in terms of the footprints that you leave? Are you going to trash the existing footprints that are there? If you've got an overflight, if you've got a rocket coming into land, the exhaust from that is going to wreak havoc with any of these sites in terms of original footprints and potentially, again, knocking over flags. Then you've got the whole archaeological aspect of this. You've got so much debris and waste that was left on the surface of the moon by the Apollo astronauts, ranging from cameras, etc. There's Hasselblads, there's lunar rovers from Apollos 15, 16, and 17, which again aren't that close in some cases to the lunar module. They were used for, taking live video and photographing the ascent stage as it was returning back up to the command module. Very successfully in the case of Apollo 17, remotely controlled from the Earth. There's two arguments here. Do you stop tourists? Yes, could not agree more. You've got to. But then, are China and Russia going to adhere to this? Or are they going to think, well, what is this law? Does it mean anything to me? And I had this debate with a very notable Apollo expert, Robert Perlman, during the course of last week. And he said, yeah, well, the Russians have got Lunar Cod and the Chinese have got Chang'e and various other things on the moon. They're not going to want to see those disturbed. They don't have anywhere near the historic and cultural significance of the Apollo missions. These are like basically going to the pyramids and saying, okay, I'm going to chip off a bit. And that's happened. Don't forget, you look at the Sphinx and it was used for cannibal target practice back in the 1800s with Napoleon, late 17, early 1800s with Napoleon. We don't want to see this. Humanity do not want to see something of such enormous cultural, historic significance disturbed. But how do you enforce that? The moon doesn't belong to anyone. So you almost need something like the Antarctic treaties that really are adhered to by all of the major nation states that have the capability to send something to the moon. But then you've got private enterprise. If private enterprise suddenly say, right, we'd like to take some really close-up images of the Apollo 12 or 13 or 11, Apollo 12, 11, 14, whatever sites, and they have an accident like Beresheet, or the Indian lander had, where basically something goes wrong and they're above one of these sites, it could be, again, catastrophic. So who knows? It's going to be interesting. It's great to see these protections put in place. Whether or not they'll be adhered to by some rogue nation states, who knows? Whether or not you can stop people wanting to pick up souvenirs. Can you imagine? You only have to look at, some of the auctions that occur, heritage auctions and various other sites that auction off Apollo memorabilia. And I collect a lot of Apollo memorabilia. The prices on these things can reach literally, pardon again the pun, astronomical levels. A piece of the Wright Flyer, Orville and Wilbur Wright's original aircraft, was taken to the moon. A piece of the wing structure of that was taken to the moon on Apollo 11. Tiny segments of that were selling for $10, $20, $30, $80,000 and more in recent auctions. Now, if you had something that was literally on the surface of the moon, the temptation for certain people to bring those back and make a commercial killing on them could be just too much. So, and then there's the archaeological value. If you have serious archaeological exploration going to the moon, there is some real value to be looked at, how things degrade over a period of 50, 60 years. There's a lot of, pardon the pun, human waste on the moon. The biological implications of the experiments that could be conducted on those is enormous. So, again, I'll hand back to you, Terry, if you've got any thoughts on this, but This is a really difficult one. I applaud it, but difficult.
Yeah. At the moment, of course, it's just an American law and applies only to NASA and to any missions under their umbrella. So that would cover, Blue Origin and SpaceX running missions to the moon under sort of the umbrella, if you like, of NASA. It won't cover, as you say, any of the other nations like China or Japan or India or anybody else that might want to do it. As far as the Artemis mission is concerned, 9 nations, including UK and Russia and quite a few others involved in space exploration, have signed what's called the Artemis Accord. And that actually does extend beyond just the Apollo artifacts. It applies to any human artifacts on the moon. At the moment, that's just an accord. And it's sort of an example of best practice. It has no legal implication at all. Now, there is, as you know, an actual set of space laws which haven't really been tested yet, but it may well be that we need something on an international level to protect all these artifacts in the future.
You say that, I mean, we've got the 1967 Space Act and the Space Treaties, which forbid and ban the weaponization of space. But we know full well that in the 1970s, the Russians put a cannon on the Mir, an actual cannon, which had hilarious consequences in terms of, the laws of physics and recoil. And you've also had very strong evidence of satellites doing things that they shouldn't be doing in terms of putting ballistic penetrator objects out into orbit and also flying very close to friendly state satellites. There's a Russian satellite called Luch, which is now very well documented, was totally top secret at one point, but that one hovering near various assets that it shouldn't be hovering near. So it's a trust issue as well, as to whether or not you can trust people to stick by. As you said, these are historic accords. There should be some agreement, but then you've got a whole raft of companies who want to mine the moon as well. So that's another, if you found, you know, a huge deposit of helium-3 somewhere near the Apollo 14 site, for example, who knows? Who knows how long this is going to last? It needs to be afforded this kind of status. And ideally, you know, the technology is not there yet, but at some point in the future, gigantic glass protective domes put over the sites to the extent that people want to protect them, in terms of almost like a biosphere, or like in the UK, the Eden Project. You need almost like a gigantic dome to encompass the site and really give it the protection that's needed. That's going to be, I don't know, 50, maybe even 100 years off, but let's just hope that everybody does stick to the rules here and, you know, plays fair, as it were, because these sites are too important for humanity. It's our first steps off this planet by anyone, and maybe our only steps off this planet, you know, depending on what happens with Artemis, you know, for the foreseeable future. Who knows, if we do get to Mars in the mid-2030s, that'll be the next big leap, and that'll be probably the only thing that would ever surpass what Apollo achieved in terms of human exploration. So let's see what happens. Anyway, moving on to what's up this week. Lots of cloud. That's what's up this week in the UK. I don't know what it's been like for you there in Ireland, Terry, but I missed so much over Christmas.
Yeah, the famous Grand Conjunction, the actual date was cloudy, but I saw them before and after. But look, we're running a bit late, so I'm going to run through this fairly quickly, and if Lex has to cut us off, he can give me a 10-second warning. First thing that I want to point out is that Mercury is the innermost planet in the solar system, and it's quite difficult to see unless you know exactly when and where to look, because it never appears very far from the sun in the sky. In fact, from our latitudes, you never see it in a totally dark sky. But we have a good opportunity from now, basically until the end of the month of January. It will be appearing as a little bright pink twinkling star low in the southwest, from about half an hour to roughly 45 minutes after your local sunset. It's easier to find if you have binoculars. Once you've found it, you can see it with the naked eye. And you get a good chance to see it on the 14th of January, when the very young, thin crescent moon will be just to the left of Mercury. So if you can see the moon, you'll be able to find Mercury just to the right of it. And you will need a good clear horizon down to the southwest. And the night after that, the moon will have moved about 15 degrees further on. But if you look at the horns of the moon and imagine that as a bow, if you like, and then think of if you're shooting an arrow out of that bow, that would take you back down to where Mercury is. So that would be on the 15th of January. But at this time of year, really, you cannot ignore the glorious winter sky with Orion and the Pleiades and so on. And I want you to look out for one thing in particular that is worth noting. In the summer, we have the summer triangle. In the winter, we have what's called the winter hexagon, which includes some of the brightest and most spectacular stars in the sky. Now, it's almost impossible to do this without an actual map, but I'm going to try. First of all, you find the constellation of Orion, which almost everybody who has any interest in the sky at all can identify. And you start at the bottom right-hand corner of that from the brilliant blue-white star called Rigel. And then you move around clockwise and you come to Sirius, which is over to the left. Basically, depending on the time of the night, it might be a bit lower to the left, but it'll be to the left of Rigel, considerable distance away, but unmistakable because it's the brightest star in the sky. You then move up above that a bit and you come to Procyon in Canis Minor, the little dog. Above and to the right of that slightly, you come to Pollux, the brighter of the two stars in Gemini, the heavenly twins. Then up above that, you have a brilliant yellowish white star called Capella. And then over to the right of that, again, remember, this is a hexagon, you have Aldebaran in Taurus, and then you would go back down to the right again to Rigel. So it's it's quite complex because there's 6 stars involved, but when you identify it, it's unmistakable. Now, the famous star that was in the news a lot last year is Betelgeuse, which is the other bright star in Orion. It's up on the top left of Orion as you look at it. It's within that hexagon, so it's not part of it. But if you're in any doubt, you can Google it. But that takes you around a tour of some of the brightest and most fascinating and interesting stars in the sky. So go and have a look, nice clear night, anytime in the evening for the winter hexagon.
And if you got a telescope for Christmas, I mean, it is a great time of year. If you look at Orion in particular, the 3 belt stars of Orion, if you go just below that, you'll see one of the only really clearly visible in even a small telescope or binoculars nebula, being the Orion Nebula, known as Messier 42 as well. And Terry was mentioning Taurus there, the Pleiades, the 7 sisters, again, beautiful to look at, even through a set of binoculars or a small telescope. I was out walking with my kids over Christmas, one of the few clear nights that we had, walking around in the garden, and my youngest basically said, "Oh, what's that? What's that?" And it was the Pleiades. It's one of those things that you can't really miss, as it were. It's this fuzzy kind of cluster of objects, clearly visible to the naked eye, known as the 7 sisters, because it used to be that if you could see 7 of them, you had really good eyesight. It's a great time of year, and we've got to try and take advantage of that, I suppose. You know, there's a lot going on in the world. We've got lockdown, and most people, they finish their work day and it's dark already. So being able to go out, especially if you've got kids, just sit out in your back garden and drink the beauties of the sky when the clouds eventually do clear and the mists and the fogs do clear. Just go out and have a look. It's well worth it. On that note, I just want to say again, our huge thank you to the Space Store team, who again, really supportive of us. And again, to all of the people who are listening or watching, if you kept watching on catch up, and I know a lot of people do watch on catch up on YouTube, give them your support. Make sure that you visit their website, have a look at what they're doing, because they do some really, really cool stuff. Everybody needs support at this time of year. Everybody's going through lots of different emotional issues, mental health issues, etc. But hopefully what Terry and I are doing is providing some fun, great fun stories, and with a hobby that's essentially free. You can literally sit in your back garden on a chair with a flask of your favorite drink, tea, coffee, whatever, and just look up at the night sky. And it's one of those amazing things that doesn't cost you anything. You can spend thousands on telescopes, so you can just sit out and watch it. So enjoy the skies while they're up there, and before Starlink trashes them.
Here, I second that.
Thank you so much, Nick and Terry, for another amazing roundup. I hope you space fans enjoyed it. Once again, we'll be back in a couple of weeks' time, same place. If you're new here, please do click that subscribe button to help support the Space Store community. And as Nick said, go out and look up and be inspired. We'll see you guys again in 2 weeks' time. Thank you for joining us, and take care.
Cheers, team. Cheers, Terry.
Cheers, bye. Stay safe, stay warm, look up.
Indeed.